So continuing with question 2, let's look at 2b. The question basically states, if we've already found some patterns using our hypothesis and we created a prediction, and we checked and found that there were commonalities in isosceles triangles related to their structure, can we find, again, similar features of scalene triangles? Are any of the angles equal? So here's a scalene triangle right here. The reason I know it's a scalene triangle, all three side lengths are different. How did I measure them? Well, you need to take your ruler. Now my ruler is a little bit different than yours because it's digital, but it works exactly the same. So if you've got your computer and you want this software, I can get it for you so that we can work together online. So notice that when I take my ruler, I carefully line my zero edge, which is right here. It's not at the edge of the ruler. So if you're using a real ruler, make sure that you take the zero line and put the zero line right on the edge of the line, on the side of your triangle. Then measure from 0, counting up 1, 2, 3, all the way up to the other corner, and you should end up, in this case, with exactly 30 centimeters. So I took my ruler and I measured all three side lengths, and they've shown to be different, each one. Then it says, are any of the angles equal? Well, taking a protractor, how do you measure angles? I have a protractor tool that I can use too. So to measure the angles using your protractor, one thing you need to remember is we have the sun, the horizon in the center. This center point right here, this point, needs to be placed on an intersect between two arms or two lines in the triangle. So if I want to measure this angle here that's been marked at 24 degrees, I have to take the center of my protractor and place it right on the vertex of that corner. Just like that. Now it's also important to make sure that both arms of that angle are underneath the protractor. So as you can see, both are underneath the protractor, and check this out, this is really important too. See the bottom line of my triangle? It lines up perfectly with the baseline of the horizon on my protractor. Really important, because when that arm comes out, it also tells me this is going to be my 0 count. So counting from 0, I'm going to go up until I reach this line. And when I reach that line, then I walk out, and I have to count. So this line right here is 20, 21, 22, 23, 24. It's almost 25, but not quite. So I would call it 24 because I can still see the 25 line just above it. So 24 degrees. Again, it's not as precise as I'd like it to be, but it's pretty close. The hard part, though, is how do you measure an angle that looks like this? You may remember that an angle like this, if it's greater than the letter L, angles greater than the letter L are usually called, starts with an O, obscene, obtuse. They're obtuse angles. Okay, so this is an example of a shape that looks a little bit larger than the letter L. And you have to rotate, because of the angle of your triangle, you're going to have to rotate your protractor. Again, making sure that both arms are underneath the protractor. When I say both arms, I mean both sides of the triangle, and both of them are underneath. Now, what did I do? Well, I took one of those arms, and I lined it up along the horizon on the bottom of my protractor, right there, and then the other arm extends up here. But look, it doesn't extend all the way, so it's hard for me to figure out what number it might be. Are there any tools I can use? Well, you have tools too. You can take another ruler, or you can use your ruler and create a dotted line and extend it all the way so that you can use that line to give you a better prediction of what the actual number is. Now, that's not perfectly on the line, it's pretty close. I may have to do this one again. That's a little bit better suited there. Now, I said it was 105 degrees. How did I get that? Well, let's look. This is our zero line on the protractor again, because it's the arm that's pointing to the outside edge. So zero starts here, and you have to count from here all the way to the other arm. We're going past 90, 100, so the 100 line is here, and we're over 100. Are we at 110? That's up here. Nope. We're between 100 and 110. And if you look up here, that's the 105 line. The 104 line, that's 100, 1, 2, 3. You know what, we may actually be 104 instead of 105, because I can't see the 104 line. I can see the 105 line, I can see the 103 line. So we need to go back here and change that. So this isn't 105, it's actually 104 degrees. But you'll notice again that if I compare the angles in this scalene triangle, all three angles are different. In the same respect, all three side lengths are different. I wonder if there's another pattern here too. For example, this side length is the longest side length. If I compare it to the opposite angle, what do you notice? Look at the shortest side length. Compare it to the opposite angle. There's the middle side length. Compare it to the opposite angle. I wonder if you can create a hypothesis and test that with other scalene triangles. Give it a shot. Again, protractors are available in the classroom. If you need any equipment, let me know.